Okay, so we're gonna start out learning what a derivative is. So it's really easy to show with something like x squared. So you can pretend that there's a 1 right there just to make it easier. So you multiply the exponent and the coefficient. So, multiply that. So you end up with 2x. And then you subtract 1 from the original exponent, so you end up with the 1. And so that's just equal to 2x. And then you can do it with literally anything. So you can have like 4x to the 4th power. And it's the same thing. You multiply the exponent and the coefficient, and you end up with 16x and subtract 1 from the exponent. So 3. And then you could just keep doing it with whatever, 5x to the 5th. Multiply the exponent and the coefficient, you get 25x and subtract 1, 4. Now for sine, there's no trick like this. So you can just look up like a table of like the trigonometry derivatives or whatever. You can just look up a table and just try to memorize it or take notes. But essentially, when you have sine of x, the derivative is just cosine of x. And if you have cosine of x, the derivative is negative sine of x. So sine is so you have sine, the derivative is cosine. And if you have cosine, the derivative is negative sine. And the negative, like if you started out with negative sine, it would just be cosine again, right? Because the derivative of sine is cosine, but then you would just make it negative. So that's all you really, like the negatives don't really change it that much. It's just, you just multiply it in afterwards. So when you have something like x plus sine x over x, if you try to solve this as x goes to 0, you end up with 0 plus 0 over 0, which just equals 0 over 0. So whenever you have anything 0 over 0 or infinity over infinity, you do something called it's French, I think, l'hôpital's, the hospital's rule. So what that is, it's whenever you have 0 over 0, you just take the derivative of all of the terms. So when you have something like x plus sine x over x, and that ends up equaling 0 over 0, you just take the derivative of x, the derivative of sine x, and the derivative of x. So when you have x to the 1, like right there, same thing, you multiply the exponent and the coefficient. So the coefficient in this case is just 1. So 1 times 1 is 1, x, and you subtract 1 from the original exponent. So that gives you 0. And if you remember, anything to the 0 just equals 1. So you end up with 1 times 1, and that just equals 1. So we could put that in the problem, right? So x plus sine x over x. So we have the derivative of just the plain x is just 1. So we have 1 over 1, and plus so the way to say derivative, the way you put it is d dx, d over dx. That just means derivative. So you have the derivative of the original x, which is 1, divided by the derivative of this x, which is 1, and d dx just means derivative. So you would add the derivative of sine x. And remember, we said the derivative of sine is cosine. So you end up with 1 plus cosine x, which is 0 in this case, right? Because we wanted x going to 0. So 1 plus the cosine of 0 over 1. And you just use a calculator. So the cosine of 0 is equal to 1 So you end up with 1 plus 1, because the cosine of 0 is 1, over 1. And that just equals 2 over 1, and that equals 2. So, if you try plugging in the limit as x goes to 0 of x plus sine x over x, you just get 0 over 0. But if you take the derivative of this, and the derivative of this, and the derivative of this, then you end up with 1 plus 1 over 1. And this works for anything, as long as it ends with 0 over 0 or infinity over infinity. Because, now, if you end up with something like 3 over 0, then you can't do this. You can't use L'Hopital's rule. If you end up with 3 over infinity, then you can't do this. Because the rule is you need to have 0 over 0 or infinity over infinity. And so this works